Alright, what's up guys? In this video we're going to pick up some more calculus here. This is going to be another integration practice video. This is going to be example number 5 that we're going to work on today. Alright, so we're asked to evaluate this definite integral from 1 to e squared. We got ln to the 5th of x all divided by x dx. So really all we need here is a simple u substitution. Let's pick u to be ln of x. The reason why that would be a good selection is because we know the derivative of ln of x is 1 over x multiplied by dx. And what that's going to do is that's going to allow us to cancel out the x that's in the denominator there. So we would have x du is equal to dx if we solve for the dx part. And if you're not convinced as to what happens is we'll have the integral, and this becomes u to the 5th. And notice that when we multiply by x du, the x's cancel out, just leaving us with the integral u to the 5th all integrated with respect to u. Now we have to change the limits, and you have to make sure you do this anytime you do a u substitution for a definite integral. You have to change the limits of integration because the limits that we have up here from 1 to e squared no longer correspond to the new variable that we're working with. So you have to make sure you change those. That is a very common mistake. So yeah, just make sure you're changing those. So remember, ln of 1 is 0, so that'll be the new limit, and then we got ln of e squared. Well, remember that the natural logarithm and exponential function are inverses of each other. So if I do ln of e squared, well then that's just 2. So now the integral becomes from 0 to 2, and we'll go down here and do it. Well, actually, I'll rewrite it a little bit. From 0 to 2, this will be u to the 5th integrated with respect to u. So if we use the power rule, this becomes u to the 6th power all over 6, evaluated from 0 to 2. We know that 2 to the 6th power, so that'll be, looks like we're going to get 32 over 3. Subbing in the 0 will give me a 0, so we'll have 32 over 3. And I'm going to check my work as well just to make sure that I ain't going crazy. And it's okay to do this, by the way. Yeah, that's right, 32 over 3, because remember when we substitute in the 2, we'll essentially get 64 over 6, which can be reduced down to 32 over 3. So if you were wondering as to what I did here, so if we sub in 64, if we sub in the 2, we'll get 64 over 6, okay? And all I did was divide both the numerator and the denominator by 2, and this will give me 32 over 3, just in case you were wondering how I got the 32 over 3. Probably should have just went ahead and did 64 over 6 and just kind of did it so you guys could see it as opposed to doing it in my head. So I apologize about that, but I just reduced the fraction in my head. But your answer would just end up being just that, 32 over 3. So your final answer for this integral from 1 to e squared ln to the 5th of x all over x, your answer to this, dx, your answer to this integral will be 32 over 3. So that's your answer. So that's example number 5. So let me know if you guys have any questions about this. I'll be more than happy to answer it. So that was example number 5. Alright guys, I'll see y'all next time. Y'all take care.